The truth is that traditional surveys and censuses, critical to much of the work done by development organizations, are expensive and take nearly prohibitive amounts of time. They can require significant human resources and heavy infrastructure, and the results can be skewed by data noise, bias, and aggregation. And at the end of the day, some locations, sometimes the most vulnerable, just can't be reached because of disaster, conflict, or by choice. Satellite imagery is positioned to offer an alternative solution to this challenge, even leapfrogging over the traditional methods, and has taken on an identity of improving response, resilience, and risk mitigation with objectivity and multiple tiers of insight. In 2010, when Humanitarian OpenStreetMap helped create some of the maps of Haiti used by the response efforts to the earthquake, it was still in terms I could understand. Satellites were taking pictures of the Earth from space. Humans could look at them, trace and identify features, and we had a map. We could even compare a picture from before the earthquake to after and start conceptualizing the damage and the response needed. Unsurprisingly, a lot has changed since then, but at its core, satellite imagery remains a unique opportunity to expand development work while increasing local capacity and ownership of solutions. First, access to images and data has increased dramatically. The number of satellites orbiting our planet has skyrocketed over the past 5 years. This has increased the spatial, temporal, and spectral resolution of images being collected globally. We collectively have access to more pixels, higher revisit rates, and wavelengths invisible to the human eye as images are being captured with dizzying speed and specificity. Once these images are collected, they do have to be processed into analysis-ready data. This has been a large barrier to access in the past, but providers of satellite imagery are starting to incorporate this step, and other organizations like Digital Earth Africa are working specifically to close this gap. Distribution of these images still tends to be varied, but cloud-based technology and user-friendly GUIs have contributed to easing this barrier to access. Costs are coming down, with some archives like Sentinel Hub being free of charge and browser compatible. The second massive shift in the satellite imagery for development ecosystem has been in the analysis and use of the images and data. What can we learn from them and how do we learn it? New models for analyzing these images are expanding rapidly. Maybe you speak this language fluently, or maybe this is where you start to zone out and your brain goes fuzzy. For our sake today, models just refer to a function that attaches inputs to outputs. They can actually be relatively simple, such as a linear regression that uses nighttime lights to predict GDP. Other models do incorporate deeper machine learning. Rather than specifying limited parameters to be included, these models learn the features from the data. As the models become more sophisticated, they can incorporate spatial or temporal structures, as well as other data types like weather sensors, cell phone data, social media, and street-level imagery. Models like this have been used broadly and are really exciting as the examples are growing by the week. Many of them focus on creating more accurate and timely population measurements, the alternatives to traditional census work and program planning, such as products being created by Grid3 and their partners to drive objectives like vaccine distribution. Other examples include using nighttime lights to estimate local economic impacts of a rural roads program in the West Bank, or regular monitoring of crop fields for deviation and crop rotation. This work can offer objective evaluation and inform policy at a level that just wasn't possible before remote sensing. One of the main challenges for using satellite imagery in development is the availability of geodiverse training data. It's critical for training a model and testing its performance, and something that Radiant Earth Foundation has been tackling directly. All of the progress that's been made in using Earth observation for sustainable development has emphasized the importance of quality ground data, not just for training models, but also for building trust and transparency with end users. The ethics of a global monitoring system with ownership still largely in the hands of the few, and the power dynamics that are inherent in using remote monitoring to distribute resources demand a participatory and inclusive approach. Open data and technical training are part of the solution, as is engagement with policymakers to inform the earliest stages of development, to identify user requirements and inform the process continually. With an integrated approach and amplifying the work of organizations like Zindi and Data Science Nigeria, the possibilities of using satellite imagery for development work will continue to see real impact.